It's George Tyndall, and I'm here to explain something because apparently people just aren't getting it. But I will try to make this easy for the people who don't understand, and for the people that should understand, like the experts. I'm going to take it nice and easy and slow so you will understand. Now, why do you think I'm stupid? Why do you think I'm crazy? Because you can't see what I see. And if you don't look for things and you don't find things, then you'll never know. We're going to make this very simple for people to understand. Okay? Now, I'm going to use eggs as an example before I get to what I had to and what I'm going to show. All right. These are many different types of eggs. Okay. You have omelet, you have baked, poached, scrambled, hard-boiled, fried, over easy, and soft-boiled. Okay. You have all those different types of eggs, but how many of them look the same? They don't look the same because they were cooked differently. Now, what does that have to do with rocks? Okay. Rocks, not all meteorites are the same. Depending upon what they're exposed to as to what they're going to look like. The pressures and the temperatures can be way different depending upon the conditions. And why they might not look what you're expecting to see is because you learn one way. And that's what you expect to see. Is what you're taught, is what you expect to see. And if you don't see it, then it doesn't exist or it isn't real. Now, I'm going to show you a picture, okay? This is a palisite. Okay. That is what you expect to see when you see a palisite. When it's fallen, it's all cleaned up, it's all fancied up, all cut. That's what you expect to see. But was this exposed to all sorts of different high temperatures and all sorts of different high pressures? No. That's why it looks like it does. Now, I'm going to show you, before I show you the picture, I'm going to show you what I found. Okay, you see this? You can't really see nothing. And why you can't see nothing is because this cooked longer and higher pressures. Higher pressures and higher temperatures change things, the way they look. Why does it look sort of black? Well, I'm going to show you. It's sort of like a cloaking device or whatever. You can't see unless you have the light shining on it, you're up close, or it's under a magnifying glass. Would I put this under a magnifying glass? Now, you people out there, you so-called experts, had better get on the ball, because you're not on the ball. Now, why does this palisite look like this and this palisite look like this? And yes, this is green paradot. But when you have this under the microscope, the black that's around the green, it's silver. It's completely silver, and the gem is a lot brighter. But they're different. This is the same thing. The top picture is the same as the bottom, but it's different because at different temperature and a different pressure, you're going to see different things. That's like here in the egg photo. They're all eggs, but when they're cooked, they're different. Now, why experts can't understand this, I have no idea. This is 3 different pictures. Okay? This right here is this. But I don't have the great equipment like everybody else does. But I did leave 2 small slices of some different ones with the USGS in Vancouver, Washington. Now, you can call it what you want it. I'm showing people what I found. Now, why do mine look so different? It's because different pressures, different temperatures will do different things to metals, minerals, and whatever else. And I don't care if you don't want to believe it or not. If you go cook an egg, depending upon how long you cook it, how high the heat is, as to what it's going to look like. And this is just common sense. Now, why does this one look the way it does? And this one look the way it does? And this one look the way it does? And this one look the way it does? Why do they all look different? This is metal on the inside, okay? But it doesn't look like metal on the outside. Why is that? Because everything fused together. And I've been trying to explain this, and people just want to say, no, it can't happen. Well, it can happen. And the reason why it can't happen, get close to the sun. Fly a ship to the sun and tell me you're going to look the same millions of miles away as if you were 100,000 miles away from the sun if you're not going to burn up. You're not going to burn to a crisp. It's so annoying and so pathetic that me, a person without a degree, has to sit here and try to explain stuff to people. And more people are they're going to look stupid because they have such a $1 million education and they don't know this stuff because they're not looking things up, they're not checking things out. And it's the same as this. This is metal. It's a rock in metal form. But if you look at this, you come up here and you look at this. Okay, I put this on a grinder. That is metal, okay? When I grind a disc, rough, crusty looking stuff, you come up with that. It's metal all the way through. It's metal all the way through. Now, this is green with a little bit of purple on the bottom. And this right here is magnetic. Okay, where's the metal in it? I see absolutely no metal in this whatsoever, but it's magnetic. Now, I shouldn't have to get so frustrated with this stuff, but you can't see the metal in this stuff because of the way this was formed and put together. You can if you scrape it off and you get real close up or under a microscope, you'll see what I'm talking about. And it looks like I'm going to have to get a microscope to more or less prove my point. Now, why people are refusing to believe that things like this can happen is because they are trained one way. If you think like this, and this is all you ever think, then this is all you are ever going to see. You won't see this because you're not thinking. You're not thinking there's more than one way for a meteorite to heat, and there's more than one way for it to cool. And I'm just trying to explain this to people. Now, like I said, people are going to say, oh, they're going to stoop and they're going to come and whatever. This is going to come out. And there are a lot of people out there, they'll be likely if they don't lose their job because nobody wants to listen to what I have to say. But the people at the geology place, the USGS in Vancouver, that guy listened to me. Now, I don't know, what else I can say to try to make people understand this. If this one doesn't make you understand, then you're never going to understand. And you're never going to find anything else, and you're never going to learn what you need to learn about the universe if you don't understand. All rocks when they come in, all meteors, do not burn the same, and they are not exposed to the same things. If this rocket right here comes within 300,000 miles of the sun and then comes to Earth, it's going to be different. It's common sense. But like I said, people aren't going to listen. They're going to want to believe what they want to believe. And that's fine. You have the right to do that. You have the right to do that. But as long as you want to continue to be that way and you don't want to open your mind that what I'm telling you can happen and does happen and has happened, you're just going to learn one way. And you're going to miss everything else. Now, it'll probably get a lot more better, and it'll be a lot more harder on the experts when they see I get a microscope and I'm really able to zoom in, not just with camera at 10 times. I'm talking about 25, 50 times, 100 times. If I can get that kind of microscope power on a piece like this, it's going to bring up so much in there, and it's going to show me the composition of it. And the composition of this is not the same as regular meteor because it's metallic glass. A metallic glass did not have a crystalline structure. And I'm going to call it good for this video. If somebody can't wake up after this one, there's no way to help anybody on this planet. And we'll call that good.